about on that video about how to do a KSP problem. It's a little different because no TNA's ice tables. Hielo mesa. That's Spanish for ice table. So what you're going to do is, probably not. It's not even close, actually. Sorry. So this is what it would look like, is when you go to do it, the first thing you're going to do is you were going to take, what? What? Oh, my God. We were just talking. You're on recording right now. I got to pause it. Hold on. Yeah. Okay, so watch this. When you go to do a KSP problem, Houston, you do this. You take the KSP, it's PbSO4, right? So I go PbSO4 as a solid. So then what's going to happen is I'm going to break into Pb2 plus SO4 2 minus. Bam. Second step is I'm going to write the KSP expression. KSP is equal to the concentration of Pb2 plus and the concentration of SO4 2 minus. The last thing I have to do is just get the ion concentrations to pop them in. So all I'm going to do is do this. I'm going to go molarity times liters divided by the new volume for each of them because they're being mixed together. So the new volume, drop it in there, and then I get my calculation. So what I would do is the first one is 20 milliliters of 1.8 times 10 to the negative third. Notice I'm combining 20 and 30. So my milliliters is going to be 50. So I'm going to do, it would be this, 0.02, 20 milliliters to liters times 1.8 times 10 to the negative third over the new volume, which is 0.0500 liters. So when I pop that into my calculator, I'm going to get, so I go 0.02 times 1.8 E3 negative. I get that divided by 0.05. I get my final answer is 7.2 times 10 to the negative fourth. That's going to be for PB. So that's going to go right in there. When I go to find for SO4, what do I have? 30 milliliters of 5.0 times 10 to the negative fourth. I'm going to do the exact same thing. So what I'm going to do is M times L, so molarity times liters divided by the new volume. So it's 0.03 times the molarity was, where are you, is 5.0 times 10 to the negative fourth. So 5.0 times 10 to the negative fourth goes there, divided by 0.05 liters, because it's 50 milliliters combined. So then all I'm going to do is go 0.030 times 5.0 to the negative fourth, divided by 0.05. I end up with 3 times 10, 3.0 times 10 to the negative fourth. That's going to go there. Now remember, at Q and KSP, it's the same equation. It's just you're trying to figure out, wow, this eraser's small. I'm going to just try and figure out what my Q is to figure out where it's at, whether it'll precipitate or not. So all I have to do is PB is that, 7.2 times 10 to the negative fourth, 3.0 times 10 to the negative fourth. So I'm going to go 3.0 E4 negative times 7.2 for negative, and I end up with 2.16 times 10 to the negative seventh is what I get. That's 10 to the negative seventh right there. When I look at the KSP value, it is 6.3 times 10 to the negative seventh. So since Q is less than K, that means that no precipitate will form. So you would pick A. No precipitate is going to form because Q is smaller than KSP. So second one, if you look right here, I have Mg. So if I look right here, I have Mg F2. I have 300 milliliters and 500. So my new volume to start out with is going to be 0.8 liters is what I'm going to end up with there. The first thing I'm going to do is write out the expression, or the equation. Mg F2 is going to break into Mg2 plus 2F minus. After that, I write my expression. KSP is going to be equal to Mg to the first, F minus to the second. All I do is I take the coefficients, they become exponents. The last thing I have to do, second last thing, is find the ion concentration. So the first one, I'm going to go 0.3 liters, because it's 300 milliliters, times 1.1 times 10 to the negative third, divided by 0.8. That's going to give me the concentration of the Mg. So I'm going to go, let's see it, pop it in my calculator. I'm going to go 0.3 times 1.1 E negative third divided by 0.8. I end up with 4.1 times 10 to the negative fourth. That's going to be my Mg concentration. when I go to do my F concentration. If I look, I have 500 times 1.2 times 10 negative, so 0.5 liters times 1.2 times 10 to the negative third divided by 0.8 is going to give me the concentration of that. So when I pop it in the calculator, I'm going to go 0.5 times 1.2 E3 negative divided by 0.8. I end up with 7.5 times 10 to the negative fourth. Now, the numbers, as I take the numbers and drop them in, what I'm going to do is this. I'm going to take this number, which is, that's mg, is going to go right there. I'm going to take this number, which is f, is going to go right there. That has to be squared. So the first thing I'm going to do is take 7.5 times 10 to the negative fourth, square it, multiply it times 4.1 times 10 to the negative fourth. Bam! I end up with 2.3 times 10 to the negative 10th. That is my Q using the expression. If I look, the KSP is to the negative 9th. Smaller than negative exponent means it is a larger value, so therefore nothing will precipitate. Whoa, that's not a marker. Nothing will precipitate because KSP is greater than Q. And that is how you do a precipitate problem. Remember, the critical thing is no ice tables and no ratios. You just write out the expression from the equation, do molarity times liters divided by the new volume, and pop it in the expression, and you're done. And that basically finishes the chapter.